Welcome to your everyday math lesson for lesson 812. This lesson is all about the arc size. So what is an arc? Well, it's not just the boat that Noah had the animals on, okay? An arc is something that you use when you measure numbers and you see that the numbers don't necessarily go in a straight line. So an arc is just like we did on lesson 313, where the number kind of went up at a little bit of a curve. That's an arc. So in lesson 811, you discovered that the longer pendulums have longer swings. We're going to use that chart to help us make predictions. So to the nearest tenth of a second, how long do you think it would take a 150 centimeter pendulum to swing? Okay, so I'm going to go up to 150 and see kind of where it hits that line. I would say that's about 2.5. So I'm going to say about 2.5 seconds. To the nearest 5 centimeters, what length do the pendulum takes? 2 seconds, okay? Oh, we figured that one out. We said that 100 centimeters. We already knew that one. Can you use this graph to predict how long it would take a 300 centimeter pendulum to complete one swing? Why or why not? What do you think? Can we use this graph to figure out how long it would take a 300 centimeter pendulum to swing? Technically, I would say no. The reason why I would say no is because, remember, at the beginning, the graph kind of went up a little faster, and then it kind of evened out a little bit. So for me, I would say no. The graph does not go up at a consistent rate. In other words, it doesn't go in a straight line. It's not the same distance, or it's not the same change for each measure. It doesn't go up the same distance. Do you think that arc size will affect the time that it takes a pendulum to complete one swing? Why or why not? Arc size, let's see. So an arc, I know, kind of curves, right? So my arc size for this one is from here to here. So probably about 12 inches all the way around, right? See how fast it is, right? What about if this were my arc size? About 4 inches. Okay. What if this were my arc size? It's about 24 inches from side to side. Does the arc size affect the time it takes the pendulum to complete one swing? Yes. Why? Why do you think the arc size is affected by how long it takes to go one swing? Well, maybe because it takes longer. It has a longer distance, right? To travel. Normally, you're going to be doing this on your own. You're going to see how long it takes for the 50 centimeter pendulum to go back and forth. You're going to record the results and you're going to do different things. So when they talk about the percentages or the degrees, what that means is kind of like we did with angles. You know, we have acute, obtuse, right angles, same idea. So if I were going to start a pendulum, this would be a 90-degree angle because it started out exactly 90, exactly sideways. So if my hand is right in the middle, it's a straight line straight across, right? A 45-degree arc would be about right here. 35 is about here. 60 is about here. Okay, so 60 degrees, 90 degrees, 20 degrees. So what you're going to do, we're going to look at the table and we're going to see, does arc size affect the data swing? So your job, you're going to look on page 317, and we're going to do this as a class. So it says, write your data from the table as ordered pairs. Here we go. So here is my piece of string. Okay. At about 30 degrees, let's see how long it takes. And I'm going to use the timer on the screen to kind of help me. So this is 90. This is about 45, and this is 30. I need to see how long it takes to go 10 swings. 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. That took right at... I want to make sure that it's exactly matching because I know I kept track, but I want to double check to make sure it matched what this was too. Yeah. Awesome. It took right at 14 seconds. 14.4 seconds-ish. All right. Same thing. Here we go. 45-degree angle. So 90, 45 is here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ooh. 14.1 seconds. Here we go. Let's try again. Ready? Ready? 1. Oh, wait, 60. Oops. So 90, 45, 60 is about here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Whoo! 13.9. All right, here we go. Last one. Let's do a 90-degree angle. Here we go. You ready? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 14.2. Gee golly, that's craziness. All right, so that means now we have to figure out the time to complete one swing. Remember, on this one, we divide by 10. Move my decimal to the left, so it's 1.4. Ooh, 1.4. 1.39, so that would be 1.4. 1.4. Whoa, craziness. Let's write those ordered pairs. I want you to take a moment. Write the ordered pairs. What are the ordered pairs we could use for this chart? Go. Let's go with 30, 1.4. 45, 1.4. 60, 1.4. 90, 1.4. Whoa. All right, let's now graph it. 30, 1.4. 45, 1.4. 60, 1.4. 90, 1.4. Wow. Did the arc size change? Huh. How long do you think it would take the pendulum for a 50-centimeter pendulum to complete one swing if it had a 50-degree arc size? I'm going to guess 1.4. Why do I think 1.4, guys? Because all the other ones are 1.4. All right. What does your completed graph show? It shows that the arc size does not affect the swing. No matter how high I held it up, the average arc size was the average swing was 1.4 seconds. If it was at 45-degree angle, 90-degree angle, it didn't matter. The average time was still 1.4 seconds. That arc size did not matter. All right, how is this graph different from this graph? This one and this one. Write me a sentence telling me how these two graphs are different. Go. The arc graph stays the same, but the pendulum graph with different lengths changes. Something along those lines would work. Now we do need to answer one more question, I believe, and this is going to be on page 316. It says, we already did that. It said, examine your table. Does the arc size differ? Does arc size affect swing? Explain how you know. Well, we already did that. Does it affect swing? No. The swing time was consistent. Now, remember before I asked, could we use the other graph to answer questions? We said no, because it wasn't consistent. Could I use this graph to answer questions? Yeah. Every answer was 1.4. All right. That is going to be the rest of your lesson for 8-12. I hope that you have a great day. I will see you later. Bye, guys.